Today, I will be showing to you guys why is it that the sum of the interior angles of a heptagon must add up to 900 degrees. So a heptagon is a polygon with 7 sides. So what I'm going to do now is that I will be drawing a heptagon, not a regular one with all 7 sides being equal in terms of length, as well as all internal angles being exactly equal, but just a random, irregularly shaped heptagon. So as an example, let's say we have one of the sides right here, like this, and another side that is shorter than this side, and maybe something like this, and like this, like this. So now we have 1, 2, 3, 4, 5 sides. Now it's missing 2 more sides, and I'm going to make this a irregular concave hexagon, sorry, not hexagon, heptagon, instead of a convex heptagon. So let's suppose we have this and this. So now this is an irregular concave heptagon with 7 sides. So we've got one side right here, one side right here, one side right here. So that's 3. Here's the 4th side. Here's the 5th side. Here's the 6th side and the 7th side right here. Now, what you can see is that a heptagon, regardless of whether it is a regular heptagon or an irregular heptagon, and regardless of whether the heptagon is a convex heptagon or a concave heptagon like this one, all heptagons can be divided into 5 separate triangles. And I'll illustrate using this example right here. So what I'm going to do is that I'm going to divide this irregular concave heptagon into 5 separate triangles. So I'm going to use a different color pen right here. So here we go. So this is one triangle right here. Now here's another one. Here's a 3rd triangle. And now with this final line, it's going to produce a total of 5 triangles. So we've got one triangle right here, a 2nd triangle right here, a 3rd triangle right here, a 4th triangle right here, and a 5th triangle right here. Now, from previous lectures, we know that the sum of the interior angles of a triangle it has to add up to 180 degrees. Now, if you take a look right here, this means that this angle right here, and this angle right here must add up to 180 degrees. And that goes with the other 4 triangles as well. And if you observe this picture carefully, all of the angles of the triangles actually together, all 5 triangles together, they make up the interior angles of this heptagon. So we've got one of the interior angles of the heptagon right here, a second one right here, a third one right here, a fourth one right here, a fifth one right here, a sixth angle right here, and last but not least, a seventh angle right here. So therefore, the sum of the interior angles of a heptagon must be equal to 180 degrees times 5. Why 5? Because the sum of the interior angles of a triangle must add up to 180 degrees. And we can divide a heptagon into 5 separate triangles. And 180 degrees times 5 is equal to 900 degrees. And so therefore, this is why the sum of the interior angles of a heptagon must add up to 900 degrees. And this is the case regardless of whether the heptagon is a regular heptagon or an irregular heptagon. This is also the case regardless of whether the heptagon is a convex heptagon or a concave heptagon.